Hi, this is lesson 9.2 and we're going to be working with polar graphs. Now a lot of this will be pre-calc orientated at first, and then we'll get into some of the calculus that deals with the polar graphs. So first of all, let's plot these points. Hopefully you remember this from pre-calc, but we're going to go from this point 3 comma pi over 6. And so this would be how far out we go, and then this would be the line that we would be on. So I go to pi over 6, which would be this line right here, this angle measurement. So I've gone pi over 6, and then I'm going to go out 3. So this would be point A. Then if I look at point B, that would be go to pi and go out 4. So this is the pi line, 1, 2, 3, 4. So this would be my B. And then if I look at C, this is one that you just have to remember. Go to negative pi over 6, 5 pi over 6. So 5 pi over 6 would be, negative 5 pi over 6 would be to here, right? So then we end up with going out by 3 on that line. So 1, 2, 3. And this would be my C value. And then finally I go D. This one has a negative value here. So I'm going to go to 3 pi over 2, which is to here, and then we're going to go negative 3, so that will go in reverse. So this is 3 pi over 2, so I'm going to go this way instead by 2 units. So this would be my D. Then we have the next situation where we want to do point conversions. So you got to just work your way around and figure some of this out, but this is a rectangular point right here. So we want to go ahead and plot that under the conditions where r is greater than 0 and theta is greater than 0. So I'm going to go ahead and plot negative 1 and then square root of 3. So this would be right about here. Okay, so then I have this value here. This is 1, and then this is square root of 3. So when we write polar coordinates, they are of the form r theta. And so I'm going to figure out what this angle measurement is and what the length of this side is. Well, this is going to be the square root of 3 plus 1. So it's going to be this squared plus this squared, Pythagorean theorem. And so this would equal to 2. So r theta, the radius would be 2, and then my angle measurement on this one would be by taking the opposite over the hypotenuse, and I get square root of 3 over 2. So the sine value is square root of 3 over 2, and then that happens at 2 pi over 3. Now look at our conditions. R is greater than 0 and theta is greater than 0. We want to do the same thing for B, except for we want R greater than 0 and theta less than 0. Why don't you try all of these and see where we end up. So I end up with, I hope you pause. If you haven't paused, go back and pause and try this. So if I have negative 4 pi over 3, this is going to get me to this value here, and then I'm going to go up by 2. And you can check the other pictures for C and D. All right, so we go on to number 3. But before we do that, let's take a look at our right triangle here, where this is theta, and then we have x, y, and we have our r. So our conversion formulas that we can use, and remember that we have r theta, is that we take Pythagorean theorem, x squared plus y squared is equal to r squared. So that's one of them. X squared plus y squared is equal to r squared. Another one is that we know that the sine of theta is equal to the opposite over the hypotenuse. So if I want y, I'm going to solve for y. Y is equal to r sine of theta. In a similar manner, you're going to get x is equal to r cosine theta. So those are two more that you want to have here. R is equal to, x is equal to r cosine theta, and y is equal to r sine of theta. Now another conversion is if I give you a point in rectangular form, I have the x and y. Well, if I have the x and y, a lot of times I need this theta. So what relates x and y together along with theta, that's going to be my tangent of theta is equal to y over x. So given a coordinate xy, I can find the angle measurement by using the inverse tangent. Okay, so number 3, change the point to pi, there it is, to rectangular form. Two ways to do this we can draw. You can always draw a picture. So if I do this, I'm going to go to pi and I'm going to go out 2. Well, what's the coordinates of that point in rectangular land? It's going to be -2, 0. Method 2 would be to say that this is r and this is theta. So x coordinate is going to be r cosine of theta, and y is equal to r sine of theta. So if I plug these in, I get x equals 2 cosine theta, y equals 2 sine of theta, so this is just going to be -2, and this is going to be my 0, so I get the same exact thing. So those are two ways to do that. Now if I have this situation where it's the other way around, I have the x and y, and I recommend that you write those things over the top, then you know which realm you're in. Now you're going to change this to polar form. So I'm going to need a r and I'm going to need a theta. So to get r, I'm going to take x squared plus y squared is equal to r squared. So this would be 3, well it's -3, squared plus 3 squared is equal to r squared. Simplified out, it'd be the square root of 18, which is 3 square root of 2 for the r. For if I'm looking at the theta, then I'm going to use this equation here. So tangent of theta, or you can draw the picture too. Well, honestly, I think it's better if you draw the picture. -3 and then 3. I'm going to end up right there. Well, that's going to be 3 pi over 4. If you want to do it the tangent of theta way, it's going to be it's positive 3 over -3, so this would be -1. So the tangent of theta equals -1 either at 3 pi over 4 or -pi over 4. You could use either one because this could have been a plus or minus, but to keep things simple, I'm going to do 3 square root of 2, comma 3 pi over 4. There we go. Okay. So you can draw the picture, or you can also use the formulas. Now let's convert some equations. Well, remember we have these formulas that we can use. So if I have y is equal to 4, this is rectangular to polar. So now I want to take the y and put it into polar. That would be my r sine of theta. So r sine of theta is equal to 4. Let's try to solve this for r. And we get r is equal to 4 divided by sine theta. I recommend you jump ahead and try some of these. So pause this and see what happens. But this would be 3 r cosine theta minus r sine of theta plus 2 is equal to 0. Can you solve for r? Well, I can factor this out a little bit. If I bring this over to the other side, I can factor out a r, 3 cosine theta minus sine of theta is equal to -2. And so now I divide both sides by this, 3 cosine theta minus sine of theta. And I have my answer. Voila. My last one here, number 7, you can do r cosine theta, r sine of theta, and put that in there, but what is x squared plus y squared? Well, I think you can see that that is r squared, and so this makes it a lot easier. 2r cosine theta is equal to 0. Now this has an r in both of these, so r minus 2 cosine theta is equal to 0. So I have two situations. Either this is equal to 0 or this is equal to 0. So r equals 0, comma r is equal to 2 cosine theta. R equal to 0 is not going to be counted for us, so this would be your equation that you'd end up with. And sure enough, this is an equation of a circle, and this is an equation of a circle. And if you remember, this is what that circle looks like. We'll do that in a minute. So now we have equations where we want to go from polar to rectangular. So if I look at this right here, the negative numbers we don't deal with very well because we know that this will probably end up being a circle. So let's change this out by squaring both sides because I have an equation for my r squared. If I do that, I get r squared is equal to 4. So this is x squared plus y squared is equal to 4. And if you notice, that's a circle with a radius of 2. Okay, now it said negative 2, but that just means that I'm going to go like if I normally would go here, I'm going to go this way instead. It's just going to go the opposite way, so it's no problem. Number 9, r is equal to 3 cosine theta. So this one's close, but we really like the r squared instead. So can I multiply both sides by r? Oh, I really like the r cosine theta as well. So this is my x value, and then this is my x squared plus y squared. So all I end up with is x squared plus y squared minus x is equal to 0. And don't forget this 3, like I did. Okay, so that's the equation that you'd end up with. So let's try number 10. Well, this one I could throw another r in, but let's try to monkey around with this a little bit. This is 1 over the sine, so r is equal to 2 over the sine of theta. So if I multiply both sides by sine of theta, I'm going to get r sine of theta is equal to 2. Oh, that's nice. So this is just my y, so y is equal to 2. Funny, we get this fancy schmancy thing, and all it is a horizontal line. So that's what we end up with. Okay, so there's some conversions for us. So here's a nice graph representation. What I did was I put on r equals a cosine theta. And the a value is changing from negative values to positive values. So look at the graph. So right now a is positive. A is negative. Do you notice what's happening here? The biggest that I go for is a equal to 3 or a equal to negative 3 on the lower end. And so notice that this is as far out as I go. This is when a is equal to 3, and this is where a is equal to negative 3. So you can see how that graph goes about. You're using the diameter to graph this with the 3 rather than the radius. Now what would happen if I changed the cosine to sine? Conjecture and think about it. And if you guess it went up and down instead of left and right, you would be right. And so we go up to a value of positive 3 at its biggest, and then negative 3 when it's at its smallest. And so that value of a determines if you're up above or if you're down below. Now here's some situations where we have a rose petal. So what I did was I took the same a value and I made it 3 constantly, and then I put in a b value. So I'm kind of changing the angle measurement quite a bit by accelerating this angle measurement in here by some b value. Now if we notice, here we have b is equal to 5. And when b is equal to 5, we had 5 petals. When this is going to go too fast for me. B is equal to 5, we end up with 5 petals. And then if I take, and when we do 4 petals, for b value, then we get 8 petals. So I wrote it here. And then if we move on to 3, how many petals do we have? We have 3. And when b is equal to 2, how many petals do we have? 4. So there's a difference when we have an even number for b and an odd number of b. And part of it is that when we do have an odd number, the petals, when we're going around here, are just going to end up going over themselves again. So they cover themselves up. And then when I'm even, the petals don't overlap, and so when I go around like this, they don't overlap and cover each other up. So odd, they cover themselves up, and so what you see is what you get. 5 gives you 5. If it's a 4, then it gives you an 8. if I had B value being 16, yeah, I'm going to have 32 flowers going. I highly recommend you get on Desmo and play around with this. It's really fun. You have to go to Tools to change to the Polar, but that's what you end up with. Now this is cool. I can just throw this away. Oh, I can just keep it there. So why don't you take that information and see if you can graph all of these 11 and 12. And then 13 will help you with a little bit and go from there. So you can check these out. A and B, I think, for number 11 should be pretty straightforward. For 12A, we get 4 petals. And then for B, we're going to get 3 petals because it's an odd number here. And with 3 petals, we got to figure out what angles they're going to be at. We know that these things are going to be spread out by 360 degrees divided by 3, so they're going to be 120 degrees away from each other. You can do that in radians too. So then it's just a matter of where does it go? Well, you plug in some values. So set up a T-chart with these as your R values, and then with these as your theta values, and then go ahead and find your R values. So at pi over 6, I'm going to go out by 4. So this is what's happening here is that I'm going to get a petal this way. Then I'm going to get a petal this way. Then I'm going to get a petal this way. So that's what you end up with. So that would be your rose petal curve. So this is number 13, your limison. And so with this, I put in the 2 and the 3. So I don't like this though. Let's change this if we can. So I put an A and B value in here. So now I'm going to fix this B to be 3. And then this A, I'm going to get to start rolling. And I want you to compare the A and the B and then look at the picture, especially this right here. Tell me when it disappears. So look what happens. Right now we got 3. What happened to our loop? It disappeared. And so A is bigger than B right now. Now A is less than B. What happens? We create this loop in the middle. So once again, A is greater than B, no loop. And now 3, there we go. Then we create that loop. What's true when we're at 3? Well, when A is equal to 3, we don't have a loop, but then we are centered here at the center, the pole as we call it. Okay, so that's what we end up with. So here's the case where A is less than B, so I'm going to have a loop. How big is that loop? Well, that's the difference. How big is the other loop? Well, that's the sum and the magnitude of those. So this would be out at 5, and negative 5. And so then I come in like this. Oh, I'm a little flat here. But that's generally what it looks like. It should be a little bit rounder than that. Here, A and B are the same. So I'm going to touch, and then this is a sign as well. I'm going to touch right here, and then I'm going to go up here. How far? To 6. So the difference is 0. That's why I end up here, no loop. And then I'm going to go up here to a 6. Not so bad. Try this one on your calculator, and you'll see that you'll go by 3, and you'll go by 3. So practice these on your calculator, get into polar mode, and go ahead. So now here's the summary of what we just went through with the graphs. I highly recommend you go to Desmos, play around. It's quite fun, and you learn a lot pretty quick. Woo, we've been through a lot. Finally, some calculus. Woo! So here we go, tangent lines. Find an equation of the tangent line to the graph. R is equal to 2 times 1 minus sine of theta at the point 2, 0. Now when we do this, this is R and theta. You got to be cognizant of that. Okay, you might need more paper for this, so write small or else get more paper. What we got to do is we have to find out what dx d theta is and dy d theta, and then we're going to have to go find out what dy dx is. So it's similar to what we did with parametric equations. However, in this case, we have to get x and y going first. So I do know that I have x is equal to r cosine theta. Well, what's r? In this case, r is equal to 2 times the quantity 1 minus the sine of theta. So what I do is I take out this r and I replace it with exactly that. I replace it with this 2, 1 minus sine of theta, and then I still have my cosine of theta. And so why would I do this? Well, we're going to need dx d theta first. So when I take my derivative here, well, maybe I should simplify this first. So there's simplified. So if I go dx d theta, and then I take the derivative of the cosine negative sine, so it's negative 2 sine of theta. And then here I got to do a product rule. So this is going to be minus 2 first times the derivative of the second. So it's going to be plus 2 sine of theta, and then I'm going to get minus 2 second times the derivative of the first. So it's going to be cosine, which is just that. So let me write this a little bit more legibly. Dx d theta is equal to negative 2 sine of theta plus 2 sine squared of theta minus 2 cosine squared of theta. Now try the same thing by finding y. You go do this. Y is equal to r sine of theta. Find dy d theta. So there's my dy d theta. So back to what we're doing and why we're doing this. This says to find an equation of the tangent line. Whenever we need this, we need the slope. And so in this case, the slope's going to be dy dx. Oh, that's what it's been most of the time. And then the point, this is r theta, I said, but also this is just going to be my xy. It's going to be the same exact thing. Rare that that does happen, but that's what we're ending up with. So what I want to do now is find dy dx. Well, that's going to come from dy d theta over dx d theta. So I take this blue 2 cosine theta, and I'm going to divide it by dx d theta, which is this one. And I'm going to get this. So now I'm just going to plug in this point right here into my derivative, and that's going to give me the slope of the line. So dy dx evaluated at 2, 0 is going to give me, oh, well, this is theta equal to 0. So I don't need that anyways. But then I plug in 0 for theta, and I'm going to get 2 minus 0. And wherever I see the sign, this is going to be a 0 plus 0 minus 2. So my slope is negative 1. What's the point? Well, the point is also going to be 2, 0. So I get y minus 0 is equal to the negative 1 times x minus 2. So there's the equation of my tangent line. Takes a little bit more effort to get to my dy dx. The key is this right here. Write the equation, x equal to r cosine theta, y equal to r sine of theta, and put the r in. That is really huge. Okay, so find the points at which the graph of 2 minus 2 cosine, and so it's a negative cosine, so it's going to blow out here by 4 this way, and it's going to have a loop inside. Nope, they're the same exact, so it's going to be just at 0. So I'm going to have a big loop here, and it's going to come and hit, and then I'm going to have another loop here, something like that. Okay, so I wrote both my x and y, and I want to find dy dx because I want horizontal tangents. However, I'm going to save you some work because I do know once I get down here that I want dy d theta all over dx d theta, which is my dy dx, and I want that to equal horizontal tangents equal to 0. That means that all I need is my numerator part in order to set it equal to 0, because whenever I set a rational expression equal to 0, numerator equals 0. If this said vertical, then all I would be doing is taking the derivative of this one because that would be in the denominator. denominator equal to 0, I'm going to get vertical tangent. So here's my derivative dy d theta. I'm now going to set this equal to 0. And when I do this, I look over here to solve this by hand. I got to get, you could go ahead and graph this with your calculator, but to do this by hand, well, I actually don't know how to do that with your calculator exactly, but you do this by hand, you got to get everything in terms of the cosine. So we did this in pre-calc. So 2 cosine theta minus 2 cosine squared theta, and then plus 2, 1 minus cosine squared theta is what we end up with here. So if I solve this out, you try to collect like terms and see what happens. So when I get it all simplified, I can now factor this quadratic in the cosine form. Woo! When we solve, we get all the way down here. Okay, so we get theta is equal to 2 pi over 3, 4 pi over 3, and 0. Now let's look at 0. Well, that's talking about probably that critical value there. I'm not sure exactly, but we discount that. So we're looking at theta is equal to 2 pi over 3 and 4 pi over 3. So we got to go find the r values. And also if I plug in 0 there, I'm going to get r equal to 0, which is not what I want. So to find r for each one of these, r is equal to 2 minus 2 cosine of 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2. And so I'm going to end up with 2 plus 1, which is 3. And the cosine is also negative 1/2 at 4 pi over 3. So those are your 2 points that you're going to end up with horizontal tangents. How are we looking on my crude drawing here? That would be about 3 comma 2 pi over 3. That would be about 4 pi over 3 with the 3. I read that wrong, but those are the points that I'm looking at. And so those do look like I would have a horizontal tangent at each one of those points. There we go. This was very long. Apologize for that, but a lot of details in there and a lot of it's reviews, so you should be probably pretty good at that beginning part. All right, polar coordinates, this is the beginning. We got another one coming up. We're going to do the antiderivatives and find area. So there we go. Take care. Have a great day.